So let's look at problem 11, on the page 304. So let's look at this problem 11. It says few students manage to complete their schooling without taking a standardized admissions test such as the SAT, LSAT, or the GRE. All these tests are standardized tests. Sometimes these multiple-choice tests discourage guessing by subtracting points for wrong answers. So if you choose wrong answers, then you lose points. So there is penalty for wrong answers. In particular, a correct answer will be worth +1 point. An incorrect answer on a question, with the 5 listed answers, A through E, will be worth -1/4 point. Now try to find the following expected value. Okay, so first let's list all those knowns, and this is page 304. And problem 11. So first, totally we have 5 listed answers, right? 5 listed. Answers. And we have only 2 types of answers, so we have 2 outcomes, correct answer and wrong answers, right? So we know the probability of the correct equal to what? The probability of the correct answer equal to what? 1/5, right? Totally you have 5 answers available. Only 1 answer is right. So the probability of the correct answer is equal to 1/5. And then the probability of the wrong answers so definitely is equal to 4/5. Now what is value of correct answer? +1, right? The problem says the value of correct answer is +1, so this is the probability, and this is the value, okay. And the value of the wrong answers, this is -1/4, right? This is -1/4. Now to find the expected value in part A. So when you have 5 listed answers and you just guess, then the expected value of random guessing. So the expected value for this part A, that should be the value 1 times this probability and plus the value -1/4 and times the probability of the wrong answer 4/5. And you cancel this 4 and this 4. So you get 1/5 and -1/5. So this is equal to 0. What does this mean? So if you have no idea about any answer in this problem, if you just guess, then averagely you get nothing, right? Averagely you get 0. So this is the part A. Now let's look at part B. Find the expected value of eliminating 1 answer and guessing between the remaining 4 possible answers. So right now, suppose you for sure know 1 answer is wrong answer. Then you just eliminate this answer from the pool of choices, then, in the remaining 4 possible answers, then you guess. Now this time try to find the expected value of part B. So among those 4 possible answers. So now part B. So on the part B we have the 1 correct answer. 1 correct answer, right? And 3 wrong answers, then What is the probability of correct answer? 1 over 3? 4. Right? 1 over 4. So totally we have 4 answers and only one answer is correct. So the probability of correct answer is 1 over 4. And the probability of the wrong answers, that should be 3 over 4. And you have the same values for the correct answer and wrong answers for these several parts. Now for this part B. The expected value should be 1 times 1 over 4. So this time, the probability changes and plus negative 1 over 4 n times 3 over 4. So by this, get 1 over 4 minus 3 over 16. And this is equal to 1 over 16. 4 over 16. 4 minus 3 equal to 1. 1 over 16. So now, if you know one answer definitely is wrong and you eliminate this wrong answer from the pool of choices, then among the remaining 4 answers, if you guess averagely, you can get 1 over 16 point. So it's positive point, right? Now let's look at part C. Find the expected value of eliminating 3 answers and guessing between the 2 remaining possible answers. Right now, in this part C, we have only 2 answers. One is wrong, one is correct. So definitely the probability of correct answer is 1/2. So is the probability of the wrong answer. Right? And then the expected value, this time, that should be equal to 1 times 1/2 and plus the negative 1, okay, times negative 1 over 4 times 1/2. This guy equal to 1/2 minus 1 over 8. And then you reduce this fraction to 4 over 8 with the common denominator. So you have 4 minus 1, so that is equal to 3. 3 over 8. So bigger than the expected value of part B, right? So now, let's look at part D. Use decision theory and your answers to parts A, B, and C to create a guessing strategy for standardized tests such as the SAT. If you have no idea about any answer in the list, what should you do? Should you guess? Yes, 0. It's 0. Should you still guess in this case? You know, by guessing, it's not negative. By guessing you get nothing, right? Averagely you get nothing. Averagely you get nothing. But when you guess, you spend time, right? Your time is limited during the test. So in the part A, in this case, if you have no idea about any answer in this list, don't guess. Just skip them, right? Otherwise you waste your time because averagely you do all of things for nothing. So this case, don't guess. If you know one answer definitely is not right answer, then you eliminate it from the list. In the remaining answers, then you can guess boldly, because you can always expect the positive expected value. This is the strategy for standardized test. Interesting? So in the future, you see, there is penalty on the wrong answer, and then if you have no idea about any answer in the list, don't guess. Just skip them. But if you know some answers definitely are wrong, eliminate them from the list and then in the remaining answers, guess. This is the strategy for the standardized test.